Hey everybody, so we are looking at section 7.4, addition and multiplication rules and probability. So this particular problem we're looking at here is a single letter from the word cookbook is chosen. What's the probability of choosing a B or an O? So here as I can tell, the easiest thing to do is look at how many we have total here to choose from, and there are, 8 letters? So that's going to be your denominator for starters. Now in your numerator, it's going to be how many B's and O's we're looking at. So we're looking at, 5? So if I'm not mistaken, this one's pretty easy. 5/8. It is Monday, so if I get this wrong, I'm blaming it on Monday. That as well as my Niners losing the Super Bowl. But I got this one right. Let's take a look at the next one now. All right, this next one actually is one of the harder ones in this section. Let's see what's going on. A swim team consists of 4 boys and 7 girls. A relay team of 4 swimmers is selected at random from the team members. What's the probability that there are 2 boys on the relay team given that there are 2 girls on the relay team? And then express our answer as the usual. I got 1/6 as an answer. How did I do that? Well, let's take a look. What we're looking at, there's a combination. First, we need to find the combination of boys taken out of the total number of boys. So we have 4 boys total, and we need to figure out, well, how many different combinations can we get where we get 2 of those 4 boys on a team. So it's a combination, 4 choose 2. Now we're going to divide that by the combination of boys out of the total number of swimmers on the team. So we're going to have, now by the way, we're looking at 9 swimmers to choose from here because you got a total of 4 boys plus 7 girls. That's 11, but 2 of those 11 have already been selected for the team. So subtract that 2 out, you got 9. That's why you have 9 swimmers here, and that's why I have 9 choose 2. So what we're talking about here is a total of 9 swimmers out of all this, and we've got to choose 2 of those 9 to be on the team. And we've got to do division because we're doing the combination of boys out of the total boys. Divide that by the combination of boys out of the total number of swimmers. So I went ahead and I did this the long way. You can use a calculator to figure this out. I've done this before on a calculator, but I'm showing you the long way to do it on this case. So it's 4 factorial over 2 factorial times the quantity of 4 minus 2 factorial. That's the formula for that that's the setup we're going to use for figuring out this combination here. And when you simplify that down, you're going to end up with 6, and you can see how I did the work there. Likewise, 9 choose 2, it's 9 factorial over 2 factorial times the quantity of 9 minus 2 factorial. Simplify that, you're going to get 36. So 6 divided by 36 reduces to 1/6, and that's how you do this problem. Hopefully that sheds some light on how this works. Next up, we have a bag of 13 marbles containing 6 marbles with red on them, 3 with blue, 4 with green, and 4 with red and green on them. What's the probability that a randomly chosen marble has either green or red on it? And then note that it's not mutually exclusive, express the usual. So notice I hopefully you notice I emphasize the word or here for a reason. Okay, what we're going to do is we're going to add up the marbles with red and the marbles with green, but then we have to subtract off the double dip of 4. So that's my old problem, sorry. Let me scroll down here. Here it is. So we've got green and red minus red and green. So that's 4 plus 6 minus 4. That's a total of 6. And we'll divide that by the total. That's our probability. So basically 6 out of 13 is what we're looking at in terms of randomly choosing a marble that has either red or green on it. We're looking at selecting situations that have independent events. Now dependent obviously means that one event is dependent on the other one. Independent means they're 2 totally separate events. So, smoking cigarettes and getting lung cancer, yeah, I would say that getting lung cancer is dependent on smoking cigarettes, so I don't think that's it. Drawing an ace and then drawing a spade from a standard deck of 52 cards without replacement. Now right there, because they have the word without, that's going to make this dependent. If it said with replacing the card, then it would have been independent because as it stands now, it depends on which cards you have previously removed from the deck. So the next step, the destination is of 3 randomly selected travelers at an airport. I think that might be our guy. I think they're pretty independent, but let's see what the next one is. winning a marathon and winning the local lottery. I think those are definitely independent of each other. So I think we're going to get 2 answers out of this one. Should we see if we're right? Hey, hey, hey. Not bad for a Monday, especially after the Niners lose the Super Bowl. Hey, I'm a little sore if you can't tell. Next up, 3 cards are drawn with replacement, so they're independent. From a standard deck of 52 cards, find the probability that the first card will be a diamond, the second card will be a black card, and the third card will be a queen. And then we'll express our answer in lowest terms, etc., etc. So the word and means in this case we're going to be multiplying. We're multiplying our different combinations or such. So what I'm looking at here, my fractions that is, 1 over 104 is my answer. How did I get that? Well, let's take a look. We're talking about diamonds out of the total, and because it's and we're multiplying, so by the next fraction is black cards out of the total times your queens out of the total. Well, in a deck, excuse me, let's open this guy up so we can kind of have a reference to see what we're doing here. Not familiar with a deck of cards. Sorry, my band is in the way here, but notice I have 13 diamonds here out of a total of 52 cards. And then black cards, that's half your deck, right? So 13 out of 52, 26 out of 52 for your black cards, and notice I've got 4 queens. 1, 2, 3, 4. That's why I have 4 out of 52. If you simplify all these fractions, with cards are not too hard to do, I don't think, right? 13, a quarter of your deck is diamond, so I've got 1/4. Half your deck is black, so I've got 1/2. And then I've got 4 queens, so basically it's 1/13 of your whole deck is a queen. Multiply it out. That's how I get 1 over 104. The following table shows a breakdown of opinions for both faculty and students in a recent survey about the new restructuring of campus to include an honors college. Find the probability that a randomly selected person is either in favor or opposed. So we got the word or. That means we're going to add our fractions, as we're going to see over here, to the restructuring. So what we're looking at here is the people that are in favor. Now, it's more than just the faculty. It's more than just the students. It's all of them. All the people who are in favor are going to be 76. All the people opposed will be 57. So that's what I've got there. You add those two together, you get 133. Divide that by our total people of 189. And you've got 133 over 189, which reduces to 19 over 27. And that should do it for this problem. Mr. DiNardo's literature class is 97 students. Classified by academic year and gender is illustrated by the following table, which we see here. Now, he randomly chooses one student to collect yesterday's work. What's the probability that he selects a female, given that he chooses randomly from only the freshmen? So right now, I could probably tell you that the answer is going to be 1/2, because if he's only picking from the freshmen, he's got 16 males, 16 females, equal number of both. So 16 out of what, 32? It's going to reduce to 1/2. So that should do it for that problem. I'm moving on. The following breakdown shows the following table shows the breakdown of opinions for both faculty and students in a recent survey about the new restructuring of a campus to include the honors college. So this is a lot like the previous problem. But this time we're going to find the probability that a randomly selected person is either a student opposed to the change. So you look over here, students that are opposed, so that's 74. Or a faculty member who has opinion either for or against. So we got faculty. So we're going to take the in favor of, which is 12, and against, which is 7. So long story short, we're taking 74 plus 12 plus 7 out of our total of 207 people. Reduce that, and you have your answer. I already did it. You can't really see it, but there it is. And you know what? I just realized you guys cannot see the window where I did that work. Give me a second. Let's see if I can find it for you. Yeah, sorry guys. Here's what I meant over here. 74 plus 12 plus 7 over 207. That reduces to 31 over 69. And again, where I got that from was there were 74 students who were opposed to it, 12 faculty who were in favor, or faculty who are against it. So you add those three numbers together, it's all over your total of 207. That's how I got my fraction that you see there. Sorry, I forgot to have that window open for you there. This next one, Mr. Greasy's business class has 112 students classified by academic year and gender as illustrated by this table here. He randomly selects one student to collect yesterday's work. What's the probability that he selects a female given that he chooses randomly from only the sophomores? So it's going to be 1/2. I could tell you that right now, just like our previous problem. I'm going to skip this and move to the next one. In this one, 2 dice are rolled. What's the probability that the sum of the numbers rolled is either a 7 or a 5 or a 7? Let me set that up with a fraction real quick. Give me a second here. By the way, I went ahead and I worked it to make sure, it is Monday. So, excuse me, I wanted to make sure I wasn't blowing smoke here when I did it. And I got 5/18, which is right. How did I get 5/18? Well, first we need to figure out the sum of our 2 dice to get a 5. And there are several different options for this. So to roll a 5, you can roll a 1 plus a 4, a 2 plus a 3, and then the first dice could be a 3 and the second dice a 2. So, by the way, the first column represents the first die, the second column represents the second die, so, and then the last one here, 4 and 1. So there are 4 options here, the 1 and the 4, the 2 and the 3, the 3 and the 2, the 4 and the 1, 4 options. So you get the idea. We're going to do the same for the 7 now. To roll a 7, there's more options this time. For the first die, you could get a 1, the second will be a 6, you could do 2 and a 5, a 3 and a 4, and then the role reversals. The 4, the 3, the 5 and the 2, and the 6 and the 1. There's 6 total options there. Add those together. That's going to be 4 plus 6 is 10. Now there's a total of 36 possibilities. How you get that is, well, there's 6-sided die. So you take 6 times 6, and that's 36. That's how I got that denominator of 36. Reduce it, you get your 5/8, and that's the end of this problem and the section. If you got any questions, let me know.